Hello students, I'm Rashmi Vadwa, Assistant Professor of Science and Institute of Technology and Management, Gurgaon. Student, today's topic is state space analysis. Basically, what do you mean by state space model and the states variable? The state space model is a state variable xt that can be constructed from the measured input output data but not themselves measured during an experiment. Basically, state space representation is an representation of a mathematical model of a physical system as a set of input, output, and a state variable related by first order differential equation or a difference equation, and output variable value depend upon the values of the state variable. The state What are the basically advantage of state space analysis? It can be applied to nonlinear system, it can be applied to invariant system, or it can be applied to multiple input multiple output system. It gives an idea about the internal state of the system. These are the advantages of the state variable system or state variable analysis. Basically, what is a state space? It is a state space is a set of all the configurations that a given problem and its environment could achieve. Uh, and And state space model is the state variable that can be reconstructed from its input output data but not themselves measured during an experiment. So the state space model consisting or represented by a linear time invariant system is like that: x dot is equals to ax plus bu, y is equals to cx plus du. So the first and the second order equations are the state equation and output equation respectively. Means x is in my state vector and x dot is in my differential state vector. U and Y are the input vector and output vector respectively. A is a system matrix, B and C is the input on output matrix, and D is my feed forward matrix. Basic concept for the state space model is that state is a group of variable which summarize the history of the system in order to predict the future values. State variable is the number of variables required is equals to the number of storage element present in the system. For example, the current flowing through the inductor, voltage across the capacitor. State vector. It is a vector which contains the state variables as element. And in the earlier chapter, we discussed about the mathematical model of the control system. Those was the differential equation and the transfer model. So in dono mathematical model, we are discussing here one by one. This is a state space model for the differential equation. For this, we are considering an series RLC circuit having an input voltage VIT and a current flowing through it is IT. RLC is my element, that is a two storage element are here, inductor and a capacitor. So the number of the state variable is equals to 2, and these state variables are current flowing through the inductor IT and a voltage across the capacitor VCT. From the circuit, the output voltage V naught T is equals to the voltage across the capacitor VCT. V naught T is equals to VCT. This is the output voltage which is equals to the VCT. When we are applying the KVL around the loop, VIT is equals to R into IT plus में L into DI by DT plus में VCT. So DI by DT is equals to, when taking DI by DT on the left side, then the equation R into IT by L minus VC by L plus VI by L. So the voltage across the capacitor is VCT, that is equals to 1 by C integration of IT dt. Differentiate the above equation with respect to time. When we are differentiating this equation with respect to time, then dVCT by dt is equals to IT by C. The state vectors are IT and VCT, and differential state vector is dit by dt and dvct by dt, basically uct by dt. So when we are arranging these differential equation and the output equation in the standard form of the state space model, then x dot is equals to differentiation of it dt and the differentiation of u ct by with respect to dt, then minus r by l minus 1 by l 1 by c in 0. This is my a. C. A is this, B is 1 by L 0, and C is 0 1, and D is my feed forward matrix, that is equals to 0, and Y is equals to 0 1, that is my output equation IT by में IT into V IT and VCDT in the matrix form. और ये जो स्टेट स्पेस एनालिसिस है ये सारा मैट्रिक्स फॉर्म में है, इसके बेस इस पे बेस्ड एक न्यूमेरिकल भी आ जाता है पेपर में, और कई बार पेपर में इस तरह से क्वेश्चन भी हो जाता है, एक्सप्लेन द स्टेट स्पेस एनालिसिस या फिर कोई क्वेश्चन। साथ में साथ इसमें कंट्रोलेबिलिटी एंड ऑब्जर्वेबिलिटी एक टर्म है, वो भी हम इस वीडियो के लास्ट में कवर करेंगे, और उस पर बेस्ड एक न्यूमेरिकल की व्हाट डू यू मीन बाय कंट्रोलेबिलिटी एंड ऑब्जर्वेबिलिटी। नाउ द स्टेट स्पेस मॉडल फॉर द ट्रांसफर फंक्शन, when the transfer function having a constant term in the numerator c, when we are considering a simple, हमने एक transfer function system का consider कर लिया है, then ys upon में us is equals to b naught upon में sn plus में an minus 1 sn minus 1 plus up to a1 s plus में a naught. So rearrange when cross multiply कर दिया, ys s के terms के साथ multiply हो जाएगा और b naught जो है us के साथ multiply हो जाएगा, then apply inverse Laplace on both the side, then d by yt by dtn, then when we are applying the Laplace transform, then s raised to power into ys हो जाएगा. So ys का yt हो जाएगा Laplace transform इसका, ये ys है, इससे sn से multiply होगा तो yt हो जाएगा, और sn का डिफरेंशिएशन होगा dn by dtn. ऐसे ही ए एन माइनस वन कॉन्स्टेंट यहीं पे रहेगा, एस एन माइनस वन का डिफरेंशिएशन होगा डी एन माइनस वन अपॉन में डी टी एन माइनस वन, और वाई एस का होगा वाई टी एंड सो ऑन, एंड देन वाई यू एस का होगा यू टी. When this is the let yt is equals to x1, dyt by dt is equals to x2 is equals to dot x1 मतलब differential part, then double derivative, then it is equals to x3 and equals to x2 dot, and up to dn minus 1 by dt dtn minus 1 is equals to xn x dot n minus 1, and which is equals to d by t by dn up to n, that is equals to x dot n, and ut is equals to u. Then equation is x dot n plus a n minus 1 xn plus a1 x2 and a naught x is equals to b naught u. When from the above equation we can write the state equation like x dot n is equals to this, हमने right side को term right side ले गए, left side left ले गए, then the output equation is yt is equals to y and which is equals to x1. So the state space model is x dot, which can be represented like this in this form matrix, make sure x dot 1 x dot 2 up to x dot n. And what about the remaining matrix? It is in a 1 by inverse, इसको बोलते हैं unit matrix, when 0 0 0 1 only diagonally we are taking 1, and minus a naught a1 a2 and so on, then x1 x2 up to xn, b has 0 0 up to bn into un, and y हो जाएगा 1 to 0 and x1 x2 up to xn, and here d is equals to 0. So let us consider the question for this state space model for the system having a transfer function ys upon में us is equals to 1 upon में s square plus s plus 1. So when we are doing the cross multiplication, then ys into my s square plus s plus 1 into us हो जाएगा. Apply the Laplace transform. When we are taking the Laplace inverse Laplace transform of s square into ys, then d square yt by dt square plus में dyt by dt plus yt is equals to ut. Let yt is equals to xt. Differentiation of yt is x2, that is equals to dot of x1, and ut is equals to u, and the state equation is dot x1. कैसे आ जाएगा, आपने राइट साइड ले गए आप इक्वेशन को, दैट इज माइनस x1 माइनस x2, आपने इसकी जगह इस yt की जगह रखो x1, इसकी जगह x2, तो इसको इधर ले गए, और इसकी जगह है x2 डॉट, तो x2 डॉट एज इट इज रखा, इसको इधर ले गए तो माइनस हो गया, इसको इधर ले गए तो माइनस हो गया, तो माइनस x1 माइनस x2 प्लस u, this is the state equation. Now taking the output equation and then state space model, yt is equals to y is equals to x1, and the state space model की equation है x dot is equals to x1 x2, that is the 0 1 minus 1 1 from above equation. From the above equation we get this matrix x1 x2 plus 0 1 u, and y is 1 0 x1 x2. Now the transfer function from the state space model, अभी जो हमारा था from the transfer function is the same ना, yes. ऊपर जो हमारे पास इक्वेशन थी दैट इज द ट्रांसफर फंक्शन फॉर द नहीं, जो स्टेट स्पेस मॉडल था फॉर द ट्रांसफर फंक्शन व्हेन देयर इज अ एंड, यस, वो मॉडल था फ्रॉम द ट्रांसफर फंक्शन. नाउ फ्रॉम द स्टेट स्पेस मॉडल हमने ये न्यूमेरिकल भी कर लिया, उससे हमें ये मैट्रिक्स मिल गई. दिस इज द रिक्वायर्ड स्टेट स्पेस मॉडल. Now come to the transfer function from state space model. Now the state space model of a LTI system is x dot ax plus bu, y is equals to 6 plus du. Easy about. Apply the Laplace transform. When we are taking the Laplace transform of this state equation, then this x dot है ना differential है, इसलिए यहाँ sx आ गया, and a as it is, x is xx plus b as it is, and u का us. Now on this term, right side से आप left side ले जाओ, SI, that is my unit matrix, minus a into xx is equals to bus, xx इधर आ गया और इसको इधर ले जाएंगे तो 1 by ये टर्म हो जाएगी, that is an inverse. Apply the Laplace transform on the both the side, ys is equals to csx plus dus. Substituting the x value in the above equation, हमने x की जगह x ब्रैकेट में s की जगह ये वैल्यू पुट कर दी, ये वैल्यू पुट कर दी प्लस में डी. देखिए यहाँ पर x है ना, ये वाली वैल्यू पुट कर दिया. नाउ कम टू द ys by us is equals to c si minus a इनवर्स. यहाँ पर हमने us था तो us इस ब्रैकेट के बाहर कॉमन ले लिया, and then c into si minus a inverse b plus d. So the above equation represent the transfer function of the system. So we can calculate the transfer function of the system by using this formula for system represented in the state space model. And when d is equals to 0, then the transfer function will be, अब जब d 0 है तो d को यहाँ पे 0 पुट कर दो, then y s by us is equals to c si minus a inverse into b. Now let us calculate the transfer function of the system whose represented in the space model is this one. आपको दिया है क्वेश्चन में, ये गिवन है x is equals to x dot x2 x1 dot x2 dot, that is equals to minus 1 minus 1 1 0 x1 x2 plus 1 0 u. Y is equals to 0 1 x1 x2. So from the above equation we can calculate the a is equals to this one, b is equals to this, c is equals to 0 1 matrix, and d is equals to 0. The formula for the transfer function when d is equals to 0, जब d 0 है तो apply the ys by us is equals to c into si minus a inverse b, and putting the value of all the equations. आपने यहाँ a की वैल्यू पुट कर दी है, b की वैल्यू पुट कर दी है, एंड s को मल्टीप्लाई कर दिया है a से i से, जो मेरी एक यूनिट मैट्रिक्स है उसको माइनस a कर दिया, देन यू विल गेट दिस वन. ys by us is equals to this one. आपने ये इनवर्स मैट्रिक्स थी तो इसका जब ये a मान लो एक मैट्रिक्स है a, उसका इनवर्स, तो हमने a इनवर्स मैट्रिक्स कैसे निकालते हैं, a अपॉन में उसका डिटर्मिनेंट. तो मैंने a मैट्रिक्स को एज इट इज लिखा और उसका डिटर्मिनेंट होता है दिस मल्टीप्लाई दिस, s प्लस 1 मल्टीप्लाई हो जाएगा s से माइनस माइनस 1 इंटू 1, तो ये माइनस है माइनस 1 इंटू 1, और ये मैट्रिक्स 0 1 एज इट इज 1 0 एज इट इज. सो आपने कैलकुलेट किया इनको तो ys बाय us आ जाएगा, मल्टीप्लाई करने के बाद इक्वेशन एंड डिनोमिनेटर में s स्क्वायर प्लस 1 प्लस s, तो ys by us is equals to this is the transfer function of the system for a given state space model. Now come to the controllability and observability. Now let us discuss the controllability. Controllability क्या है, A system is said to be a controllable if the initial state of the control system are transferred to some other desired state by a controlled input in a finite duration of time. Means that अगर हम एक सिस्टम को तभी कंट्रोलेबल कहेंगे अगर उसकी इनिशियल स्टेट जो है कंट्रोल सिस्टम की चेंज हो जाती है अदर डिजायर स्टेट में बाय द कंट्रोल इनपुट एक कंट्रोल इनपुट के अंदर in finite duration of time. And when we checking the controllability of the control system by using the Kalman's test, then हमारे पास ये दो points हैं. एक मैट्रिक्स ले लो, write a matrix QC in the following form, that QC is equals to B AB A square B up to A n minus 1 into B. Find the determinant. अब इस मैट्रिक्स का डिटर्मिनेंट निकालो एंड इफ इट इज नॉट इक्वल्स टू जीरो मेक श्योर अगर वो डिटर्मिनेंट जीरो के बराबर नहीं आता है, इक्वल्स टू जीरो नहीं होता, then system is called controllable. What do you mean by observability? A system is said to be observable if it is able to determine the initial condition of the control system by observing the output in finite duration of time. We can also check its observability of the control system by using the Kalman's test. वही सेम मैट्रिक्स Q0 लिखो, ऑब्जर्वेबिलिटी O स्टैंड्स फॉर ऑब्जर्वेबिलिटी, ऊपर QC था, C स्टैंड्स फॉर कंट्रोलेबिलिटी. CT ACT, दिस T इज अ ट्रांसपोज, तो C का ट्रांसपोज AT CT AT का स्क्वायर CT एंड सो ऑन. Find the determinant of this matrix. If it is not equals to 0, then the system is called a observable. Now do one question based on this concept. This is the given question and हमें verify करनी है controllability and observability of a control system which is represented in the state space model, and x is equals to x1 dot x2 dot minus 1 minus 1 1 0 x1 x2 1 0 u and y is equals to 0 1 x1 x2. So from the above equation we can calculate here A is this matrix, B is 1 0, C is my 0 1 and D is 0, and we can see here from n is equals to 2, so the matrix QC will be B into AB. Now product of the matrix AB, अब AB का प्रोडक्ट निकालेंगे, जस्ट सिंपल क्रॉस मल्टीप्लाई कर देंगे A और B मैट्रिक्स का, ये हमने AB निकाल ली एंड देन B into AB लिखेंगे इस फॉर्म में, दिस इज B into AB. नाउ फाइंड आउट इट्स डिटर्मिनेंट. कैसे निकालते हैं? 1 into 1 minus minus 1 into 0, so that is next term is 0 and the determinant is 1, so its determinant is not equals to 0, then the control system is controllable. Now come to the observability. Again the matrix Q0 will be CT transpose AT CT. A का transpose ये हो जाएगा, CT का transpose ये हो जाएगा, then the product of these matrices is this one 1 0, and then Q naught is equals to 0 1 1 0, and find out its determinant, that is 0 minus 1, so 0 minus 1 is minus 1. So determinant of the matrix Q naught is not equals to 0, so the given system is observable. Therefore the control system is both controllable and observable. So student, up to this video, the controllability, observability, state space analysis, what do you mean by state space model, the transfer function from the state space model, the state space model from the transfer function, आप इस वीडियो को अच्छे से देख लें, पढ़ लें, अगर कोई डाउट हो तो फिर आप पूछ सकते हैं. थैंक यू सो मच.